Okay, let's take a look at ionic radius. Ionic radius is very similar. It's the radius of an ion. So the radius of something that has a charge. So we could draw it like this, where we have our ion. So again, this time we have something that has a charge. Let's say that we have a 1 plus charge on this, and the ionic radius is the distance between the nucleus and the outermost electron of something that is charged, aka of an ion. Now, as we go down the periodic table, the size of our ions increases. Okay? Why does the size of our ions increase? Well, it's exactly the same reason as why our atomic radius decreases as we go down the periodic table. We have more occupied energy shells. Okay? However, as we go across the periodic table, we get a little bit of a weird pattern. Let me try to draw it. So we have decreasing up until about here, and then they get quite big around here and decrease. Quite big and then decrease. Okay, and so what's happening here is actually there's a difference between the metal ions and the non-metal ions. Metal ions tend to form positive charges, which means they generally lose electrons. So when they're forming their ions, these guys form 1 plus and 2 plus ions. Metals in the transition metal area form variable numbers of ions. These guys usually form 3 plus and 4 plus, okay? And so as we go across the periodic table, my ions get a little bit smaller for the same reason as across a period in atomic radius. The reason that my non-metals, so again we can do the staircase to show the difference between metals and non-metals, the reason that my non-metals are so much bigger than my metals is because these guys generally like to gain electrons. So gaining electrons means that there's more negative things that my protons need to attract, and so it results in a larger radius. Okay, so I'm going to get you guys to write down notes for across a period and down a group. It's quite similar to atomic radius. The last thing that you need to know is that when we lose an electron, we get smaller, and when we gain an electron, we get bigger. So if you take a look at sodium, actually let's take a look at lithium so that I don't have to draw so many electrons. Lithium has 2 electrons in its first energy level and 1 electron in its outermost energy level. When it loses that electron to become lithium 1 plus, we're left with just 2 electrons. And those 2 electrons are in the first energy shell. So this guy is smaller. When we have, say for example, a non-metal like fluorine, where we have 2 electrons in the first, so that's 1s2, 2s2, 2p5. What happens is we actually, so here we're losing an electron, here we're gaining an electron. And so now we have even more negative things crowding around. And again, negative things don't like to be around other negative things. And so my radius is actually bigger in this case.